Okay, guys, I'm going to go into the I'm going to go to the whiteboard, and we want to look at an area of a segment. Yeah, we want to see if we can calculate the area of a segment, and that may require us to use some Heron's formula. What might require us to use that guy's formula now. So we have a circle, and let's say right now, let's say we have a let me see something here. So we want to find the segment, right? Okay. All right. So let's say we had a triangle on the inside, or a sector. So let's draw that. But let's make it something simple. Let's give it something simple, like 90 degrees, okay? And we want to find, so this is a radius here, this is a radius here. Let's say it's 5 centimeters. All right. We're gonna estimate this. Not really a safe thing to do with circles, but let's say this is 7 centimeters. Let's see if we get a sensible answer at the end. Just estimating. And so we have our task now, which is to find the segment. So even if the answer that we get at the end may not be so sensible, I'm showing you the steps to take so that you can complete your measurement assignment from, I believe, week 3. All right, I really would like you guys to complete that assignment for those who haven't. And so here we have the blue part is actually this is the area of a segment that we're looking for. To get there, to get to that area of a segment, we actually have to consider this whole thing here. We have to consider this whole thing. This piece here is the sector. Okay. Put it here. Okay, so that's the area of a sector. So we need to consider that. All right. So we need to find the area of the sector. Some of you are saying, where did I get this shape from? Well, it's this shape right here. It's this whole shape right there. That's what we're looking at here. All right. I should make it black. Okay. So if I find this entire space, the area of this entire figure here, and then I subtract the value of the area of the triangle on the inside, then I'll definitely be left with the area of a segment. So that's the idea. Okay. I wonder if I could select stuff. Oh, it doesn't select the whole thing. Tap it. All right. Okay, so that's the idea. So we're going to subtract the triangle from this shape. And when we subtract out the triangle, like if I was to find the whole area and then subtract the triangle, then I'll be left with this small portion of the sector, which is called the area of the segment. So with 90 degrees, we can look at it. We can put our formula now. We want to find we want to find the area of a sector. Okay, so we'll use S for sector, or let me just write S sector. Can't just put S there because we're looking for the area of a segment as well. So I can't just put S. And so we first look at the area of a circle, right? If I was only looking for the area of the whole circle, then I would use this and find my answer. But because I'm looking for only a fraction of the circle, I need to write a fraction here, and that fraction will be the angle over 360. This part of the formula tells me that I'm not looking for the area of the whole circle, only a fraction of the circle will be considered. We'll use 3.142 for pi. Okay. And our radius is 5. So it's a nice number to use. 90 is our angle. Okay. I use 90 because I don't want to do a lot of thinking, right? I want to just make it very easy, as easy as possible for our example. Then you could handle the more complicated things in your assignment, which are similar. Okay, so let's work out this. So we have to rewrite everything again. That's the tediousness about mathematics, that you have to go step by step, or else you will make a mistake. You know, you'll miss something. And so I don't want to forget that we're dealing with centimeters. And if you notice the square, everything on the inside will be raised to the power 2. So let me just go ahead and write that in. Some of you may say, well, where'd he get that cm from? Started to play magic tricks on us, making the cm appear. All right, so it's right there. And then you may say, where did the 5 go? Well, the 5 is still there, but it's just squared. And 5 squared is 25. Cm squared is cm squared. So it's just everything inside here was raised to the power of 2. If this was a 3, everything would be raised to the power of 3. Now we could go ahead and work this out. You get 1 over 4, right? Because 9 goes into 9 one time, 9 goes into 36 4 times. Okay. And let's work this out. And this 1 over 4 is equal to, if you like decimals, then you would have put, does anybody know the decimal for 1 over 4 by heart?
.25.
That's right, 0.25. So this is an example of how a fraction, okay, it leads to a decimal. And because when a fraction is a rational number, the decimals act in a certain way when you find the decimal of a rational number, like 1/4. In this case, it terminates, right? You put that in your calculator, you just get 0.25. But if you put this in your calculator, what happens if you put that in your calculator? Go ahead and try that, guys, while I work this piece out. What do you get for 1/3?
0.33.
So you get 0 point, and I just have to put this, I have to put a little bar at the top of the 3 because you notice that the 3 is, it just goes on forever. So that's the peculiar aspect of rational numbers, is that they either terminate, right, or produce recurring decimals. Like it may not recur at 3. It may just go, it may just be something like this, where it goes 0.3535, and it just repeats and just keeps going. So a recurring decimal. So then you would have to put the bar over both the 3 and the 5, because that's how it repeats, right? So that's the way fractions act. Somebody check your mic for me, please. Thank you. All right, so let's get this number. So I'm multiplying 3.142 times 25, and I got 78.55. Okay, and that is also centimeters squared. And this whole thing is going to be divided by 4, because to multiply by 1/4 is the same as dividing by 4. Everybody sees that?
Yes, sir.
Okay, so that's a yes or a no?
Yes, sir.
Okay, yes, sir. Okay. All right, so multiplying by 1/4, it's the same effect as dividing by 4. So let's divide this number by 4. And we get 19.6. So let's stop at one decimal place. 19.6 centimeters squared. So that's how you would find the area of a sector. Hope that would help you to solve number 4 in your assignment from I believe week 3. And it would also get you going for your problem, for your problem number 5.